Mark has 12 sports cards. He arranges the cards with an equal number in each row. Find ways Mark can arrange his cards.
All right, so we're trying to find out the different ways that he could arrange his cards in any kind of order that he wanted. So this column says how many numbers of rows of cards he has. Same thing here. But these are number of cards in each row versus the total number he has. So it already tells us that he has a total of 12 cards. That means over here on the right-hand side, you're going to have a total of 12 cards. Because if you don't, then you don't have the right number of cards that he needed. So over here on the very last one, we're going to write 12. And I'm not going to write 12 on every box, but please have your student do so. So there should be 12 different cards total. Now, if I were to do this myself, I would go by one row of, and remember this is of, so many cards in each row equals a total of 12. All right? So let's go ahead and start there. If I have one row and I need a total of 12, that means it's going to be 12 of them in one row. Okay? Now let's say I want to do this in 2 rows. I have 2 rows now, so 12 rows or 12 cards put into 2 separate rows. Well, I know half of 12, so the first row would have 6 in each. So we can put 6 here. Then if I brought it up over here, I now have 3 rows. Well, I know that I have 12 cards, and if I have 12 cards, and I go 3, 6, 9, 12, ooh, I just counted up to 4 on my fingers. So that means that there needs to be 4 in each row, so that way we can have a total of 12 cards, okay? A really neat trick here. Because multiplication has a distributive property, means it can be done either way, you can actually flip all of these to be written the opposite way. We could have 12 rows with just 1 in each, basically making a very long column. Or we can have 6 rows with 2 in each. Or we could have 4 rows with 3 of them in each. Any which way we do it with that still ends up with us having our total of 12 cards altogether. By doing that, we also can check ourselves to make sure that, yes, indeed, if you have 3 groups of 4, you get 12, or if you have 4 groups of 3, it is still a total of 12. All right, let's go ahead and go to the next part. All right, guys, so let's go ahead and walk through our visual learning page. Again, there will be sections that you're going to go ahead and draw this in your student pages as well, but go ahead and work through this with me.
How does an array show multiplication? We can learn how by using these swimming medals. Dana keeps her swimming medal collection in a display on the wall. The display has 4 rows. Each row has 5 medals. How many medals are in Dana's collection? The medals are in an array. How does an array show equal groups?
Well, an array shows us how many rows it has. So moving from left to right, how many rows, like rows in a movie theater, or how many columns it has. So columns like on a house.
An array shows objects in equal rows and columns. Each row in an array has an equal number of objects in it. The counters show 4 rows and 5 columns. Each row is a group of 5. You can use addition or skip counting to find the total. Since there are 4 rows with 5 counters, we add 5 plus 5 plus 5 plus 5 equals 20. Skip counting 5, 10, 15, 20.
All right, guys, so now we're going to go ahead and try it. All right, guys, so now we're actually going to try it. Let's read our question first. It says,
select the parts of the equation to see skip counting to find the total.
okay, so if I select our first group of 5,
5.
and now we add
5 plus
more.
5 equals 10.
5 more after that.
5 plus 5 equals 15.
And 5 more after that.
5 plus 5 plus 5 plus 5 equals 20.
So we could show it with addition. Again, repeated addition and multiplication is the same thing. With 4 groups of 5 each. Okay, now we're going to actually apply this. We're going to use the convince me portion of your pages. It says,
Jason also has a swimming medal collection. His display has 5 rows with 5 medals in each row. Draw an array for Jason's medals. Use skip counting to find the total number of medals. Then, write a multiplication equation for your array. There are 20 medals in Dana's collection. Who has more medals, Jason or Dana?
okay, so this one has a lot of stuff to go to it. We're going to go ahead and basically figure out the most important information first, all right? It says Jason also has a swimming medal collection. All right, so we just know that there's another person. His display has 5 rows with 5 medals in each row. That's really important here, okay? It says to draw an array for Jason's medals. Okay, we can draw an array doing that. We just need to know that there are 5 medals in each row, and there are 5 rows. So we can go 1, 2, 3, 4, 5, because we know there's 5 rows. We know there are 5 in each one of these rows, so there's 1, 2, 3, 4, 5, for a total of 5 columns. And then you have to fill in all of those little boxes, or little X's, to go with your shapes. Okay? You will have to copy this down on your page, because it will make a lot more sense if you actively try it your own. Okay? And I know that these aren't perfect X's, but I'm trying to draw on a computer. All right, so we have these that are 5 across, right? And they are also 5 tall. Okay? That means we can say it's 5 rows of 5 in each equals 25. Okay? So that's where they came in, is they used the skip counting to find the total number of medals, because we can go 5, 10, 15, 20, and 25. All right, so we've already done that. We can cross that out as well. All right, then it says, then write a multiplication equation, which we have done. So we can cross that out. I always like to cross out things that I've already used. So that way I'm not tempted to use them again, or so I can keep it a little more organized in the order that I have to do them. Lastly, it says there are 20 medals in Dana's collection. Who has more medals? Well, we know that 25 is more than 20, right? So we can put 20 on the bottom. And we know that 25 minus 20 is 5. That means that Jason has 5 more than Dana. I'm just going to put D for her initial. But he has 5 more than Dana. So answering their final question of who has more medals, Jason or Dana, we can give them the answer that Jason does. All right? Let's go ahead and go on to our independent practice and guided practice. All right, so it's going through another example here. It says Dana arranged her swimming medal collection. The arrays have the same number of medals. So we know that even though this is 5 across, right? Because there's 5 in each row. And even though we know that it's 4 rows tall, isn't that the same thing over here? It just made it vertical instead of horizontal. Yes, because of that commutative property, saying that multiplication numbers, so the numbers that you're going to multiply together, the factors can be in any order, and the products will always be the same. For example, 4 times 5 is still the same thing as 5 times 4. They both equal 20. Okay? On the second section, have guided practice. It says, number 1, Mia puts muffins in 4 rows with 7 muffins in each row. Draw an array to find the total number of muffins. All right, so this one's going to be a little trickier for me because it's kind of small for me, but we're going to try. So they have 4 rows. There's 1, 2, 3, 4, and 7 in each. So there's 1, 2, 3, 4, 5, 6, 7. And do the same thing for the other ones. And again, mine won't look perfect, but 2, 3, 4, 5, 6, 7. Yours can be a lot neater than mine. Okay? So there are 4 rows, 7 in each row. We know on number 2, it says complete the following statement. So 4 rows of 7, that we just drew, equals 28. If we were to take our current array and flip it on its side, so stand it up nice and tall, it would then be 7 rows of 4, right here. Does that still equal the same number? Well, yes, because remember how we said that the commutative property, we can flip our factors over and it wouldn't matter, it wouldn't change, the total is still the same, the product is still the same? Yes, it is still the same, so it still equals 28. Okay? On number 3, it's asking you to write a multiplication equation for the array. So something times something equals a total, right? Well, if we have 4 rows, right? So we know 4 here. And we know that there are, let's see, 1, 2, 3, 4, 5, 6 across. Well, 6 groups of 4, or 4 groups of 6, all equal 24, don't they? Yes, they all come up to total 24. All right, I'm going to go ahead and let you work on the independent practice on this page 15, okay, as well as the problem-solving questions on page, I believe, 16, yes. Again, remembering that doesn't matter what order you multiply by, so 5 times 6 or 6 times 5, they always equal the exact same total, or the product is always the same, okay? Number 7 here on page 16, very, very similar to the one that we started with on our lesson. Just be careful that you make sure that you get all of the different arrays that he could make out of those, okay? If you guys have any questions, please feel free to get a hold of me. Make sure that you also are going to be doing your quick checks. Those are really important because it helps me understand if you guys are getting what I'm teaching or if you might need some extra help, all right? If you have any questions, get a hold of me, call, text, email, any of those. And until next time, see you later. Bye, guys.